Hey guys, welcome back to another flip lesson. This one's our first one for Unit 7 on relations and functions. And we're going to talk about a skill known as finding the compositions of functions. Now, the idea behind this is going to need our evaluating skill from what we learned in day 1, but we're going to see how that comes back into play in a little bit. First things first, just a couple reminders. Common assessment number 1 on Friday, and for those of you interested in taking that optional quarterly exam, it's got to be done by Friday as well. All right, so let's get into this concept of compositions. For compositions of functions, to just kind of give you a general idea, it acts as a fifth operation, so to speak, in dealing with two functions. Now, I know this isn't one of those arithmetic operations like adding and subtracting, but it acts as one when we're dealing with functions themselves. And the idea behind a composition is simply this. We are going to use the result of our first evaluation, or that output value as we talked about it on day 1, and use that to become the input for the second function so we can find our final answer. So literally, we're going to basically do two different evaluations to come to a final conclusion or a final output value. Now, when we're dealing with these, the notation that you will see will look something like this. We will get two completely different functions. Notice that each of our notations has an f function and a g function. And what you will notice is either the composition symbol, or you will see the functions written inside one another, as you see in the final two pieces here. All right? Either way, the way we read these is as follows. So to give you the example from the first one, we would read this as f of g of x. And like I said, what we're going to do is do an evaluation of the first function, get the output, and use that output as the value to plug into the secondary function. A very important concept to know is that these functions, to be done in proper order, must be read backwards from right to left. So to show you how easy this skill really is, guys, here's our first example. And we can do, it has 4 different mini examples with it. So we're given two functions here, f of x, which is x minus 2, and g of x, which is 5x plus 3. So we're given two linear functions. And our goal is to perform the composition that is given in A, B, C, and D. So here's how it would work. Let's take A. We're going to read our compositions backwards, as we said, from right to left. And we will first perform the evaluation that we see first. So in this case, we see G of 2. So as we said the other day, this evaluation, we are given an input value of 2, and when we place that value where we see the variable, we get the output value of 13. And again, what that really represents is the coordinate 2, 13 on the graph of that function. But where we're going from here is now this. This output that we just found now becomes the input to the next function in line. And in this case, we're going to perform f of 13. So from there, we plug in the 13 where we see the variable, and in the end, we get our final output just like that. And that's all there is to it. If you guys look at it, it really looks like a double evaluation. We're evaluating two separate functions, but we're using the output of one as the input value of the other. All right? So to see a couple more, just to give you guys the general idea, one last time, same idea in B. We're going to read backwards, working with f of negative 4 first. So we plug in f of negative 4, and in that case, we get negative 4 minus 2, giving us an output value of negative 6. But as we said, that output becomes the new input for the next function in line. G of negative 6 is 5 times negative 6 plus 3. And when we actually evaluate and calculate that value out, we get an output of negative 27. Now, the only thing that can make this a little bit more challenging, guys, is seeing something like what you see in D, where hopefully we notice that instead of a numerical input, we actually have a variable. When doing so, this is known as finding the rule of the composition. And literally what we do here is we take the first function we see, which in reading backwards happens to be g of x. We're actually going to take all of that function and plug it into the variable for f. So the way this would work, f of g of x would look like as follows. G of x is our 5x plus 3 right here. But what we are going to do is take that entire function and substitute it for the variable in f. So the way this guy would actually look is as follows. 5x plus 3 gets substituted in for the variable in f, in the f function, and we are left over with that minus 2 that function still has. Now what we can do is drop our parentheses, combine like terms, and we are left with an output that reads as follows. And this is what's known as finding the rule of a composition, where you're actually plugging in one function into the other to come up with the final expression. So with that, guys, there is your concept of compositions. Nothing more than that, other than basically 2 evaluation skills and using the one output to become the input of the next function. We're going to see a little bit more of this tomorrow in class as you guys do your group work. If you have any questions, of course, we'll take care of them tomorrow, and also utilizing virtual towers during the lesson. Other than that, hope you guys have a great night, and I'll see you tomorrow.